Our first data structure is ArrayLists, and yes, it means list, since arrays are just lists of a fixed size. So what is an ArrayList specifically? Well, it's an array-like object that implements the list interface and automatically resizes itself when it is about to fill up. Well, automatically in the sense that you don't need to do it. Still a program, so it still needs to be told how to at some point. ArrayLists are great because they're so similar to our regular arrays that you don't really need to think too hard about how they work under the hood. Just imagine a normal array, but better. It's sort of like when there's an old anime that is pretty well loved, but then they go and remake it with the power of modern technology, and it just turns out bloody amazing, like Full Metal Alchemist or Hunter x Hunter. So let's try using an array list to get a feel for it. Starter code is provided in the description, and it consists of a few text files, each of them representing a portion of the national dex, and some code for reading the files. Our goal is to put the dex entries into an array list, then read from them. This will show off how we don't need to do anything special to make array lists work for us, and give us some opportunities to play around with the API. Think about what we would have to do if we wanted to use a regular array. We would need to look at each file, count up the number of lines in each, add it all together, and then set up an array of that size. God, that sounds miserable and impractical. What if this is then updated to include a new dex for Gen 9? Now we have to go into our code, make a bunch of changes, and ugh. So what we're going to do is go into our read file method, and right at the top of it, add a list string Pokedex entries equals new array list. Make sure you import the java.util.list and java.util.ArrayList from the little dropdown to auto-import it instead of having to type it out at the top every time. Now, this is actually kind of interesting. The list object is parameterized, meaning it will hold objects of that type. It's kind of like doing the string square brackets, but backwards. This is because objects are generic, meaning they can take any kind of object as a type. But don't worry too much about the details and focus on the syntax for now. Now, inside of the loop, we're going to take the string result of next line and add it to our array list. This fills our array with all of our wonderful Pokemon data. Then, at the bottom of the method, return this Pokedex entries. But since this is a void method, let's go back up to the method declaration line and change it from a void to returning a list string. Now, back in the main method, we're going to do something similar. Above our read file calls, we're going to add a new list string national dex equals new array list. Then we'll set our first returned value from our first read file method call to be list string regional dex equals read file Kanto dex. Next, we will do national dex.add all regional dex. This is a handy method that takes the contents of one list and automatically adds it to the end of the other one. No more creating a loop to do it manually. And for the next two, we're going to simplify it even further and just directly add all the read file calls. And it will automatically do read files and then add all with what that method returns. After this loop runs, we'll have a new national dex with all of our regional dexes appended in the order we gave it. Awesome. Okay, let's print out the number of Pokemon in the list. Wait, it's 385? There are 386 Pokemon in Gens 1 through 3. How on earth can we ever know which one is missing? Well, we know that the Pokemon are numbered, so let's make a for loop, but start at 1 since our Pokemon are numbered with 1 to 386, then loop until I less than or equal to 386, then I++. Now, we'll get our Pokemon from the dex with string Pokemon equals national dex.get I-1 because we have to zero index into our array. Then we'll check if our string contains the current dex number if Pokemon.contains string.value of I. Since we can't directly compare an int and a string, we convert the int to a string. And then we'll do a continue in our if block, which says finish the loop iteration and go to the next one. But if the Pokemon doesn't contain the number, then we know we found our missing entry. So let's print out missing Pokemon with dex number plus I, then do a break, which we know from switch statements will exit our loop entirely instead of doing what continue does and just going back to the top of the loop. Now let's run this and see what we get. it's missing entry 359. That's Absol. So let's double check and ask our list directly. If not nationaldex.contains 359 space Absol system.out.println, yep, Absol is missing. Run that, and voila, we have verified that Absol is MIA. So now we can do an insert into our array. So we'll do nationaldex.add 358, because 0 indexed, then 359 Absol. Now our dex is complete, well, at least for what Pokemon we've included so far. ArrayLists also have methods for removing things, checking if it's empty instead of needing to do a size check and then doing size equals 0, an index of, which is kind of like contains, but returns the index of the thing you're looking for instead of a true false. And if it's not there, it'll return -1, since a -1 index doesn't make sense, so it's a good fallback value. And a bunch of other helpful methods. ArrayLists are pretty handy, huh? They grow automatically, they handle all the logic of adding, removing, etc. And with an IDE, you don't even need to remember what it can do, let alone how. You have everything at your fingertips, so the only responsibility you have as a developer is knowing when to use it and why. All we're missing is the who. But I'm not sure that's applicable. My next video will be building ArrayLists, so if you want to see how that's done, tune in next time for my How It's Made series. Like, subscribe, and comment below what you want to see next or topics you'd like to know more about.